I'm Ben Lanz, Executive Advisor for APC Media, Power Systems Technology Magazine. We're here at IEEE Grid Edge in San Diego, California to interview thought leaders in our industry to hear their insights into the challenges that we've been facing for the last couple years and what do we need to be working on. Through these interviews, we're going to bring their insights to you, our readers. I hope you enjoy. Our next guest is Craig Satow with SD Myers.
Yes.
And you are Director of Marketing. And we've known each other for, I don't know, what, 7, 8 years already. We've worked on...
Time has gone quickly.
Participated in conferences. I was a speaker, and you did a lot of the heavy lifting in some of those early days. And I've had a number of opportunities to work with SD Myers over the years.
We have.
But here we are at Grid Edge. We're talking about everything that's happening in this space where there's lots of challenges. But before we talk about the challenges, tell me a little bit about your background, your role at SD Myers, and really a little bit about SD Myers in itself.
So my background, I came into this space about 9 years ago.
Okay.
And prior to that, I did a lot of marketing for heavy industry and not a lot within the power sector.
Okay.
But had an opportunity and was invited to come over and do this, and it's been a great journey. And
whole nother world, huh?
You know, it's funny. I was really kind of getting into a rather narrow space, you know, and I was concerned about that. But once I got here, it's been just a constant learning experience, which has been really kind of it's been a great journey.
Yeah. Well, the challenges have only grown, and the new technology and opportunities have only expanded in the last 9 years that you've been in this particular industry. So tell me a little bit about SD Myers.
So SD Myers is celebrating this year, in fact, our 60th anniversary.
Wow.
So our tagline is, for this 60 years, is building on our legacy.
Okay.
And it truly is a legacy in the sense that Stan Myers, who was the founder, he kind of invented the space, at least in the way that we do our analytics and diagnostics relative to the oil testing that we do, you know, to help the reliability and promote the reliability of the transformer. So he was the one that first came up with the techniques and then later got involved in many of the things that IEEE, our IEEE standards basically came off of his initial work. So
wow. Okay.
It's a space that over 60 years has continued to evolve, but it's at the same time, many of the basics that he started out with are still with us today.
Wow, that's so he had a good fundamental understanding from the beginning. And the amount of data, when I think of SD Myers, I think of a knowledge base backed up by data. You guys have a tremendous amount of data, tremendous amount of knowledge, and we think about the Grid Edge and all of the sensors and analytics that people are doing. My technical mentors always told me, Ben, it's junk in, junk out.
Absolutely.
And you're sitting on a treasure trove of what do transformers look like when they're healthy, what do they look like when they're doing poorly, and with the vast exodus that we've had over the number of years of the gray hair, that's got to be only more valuable now than it has been in the past. So tell me a little bit about, from an SD Myers standpoint, because you're talking about the heart of our power system, really. At the Grid Edge, you know, this is the heart of the Grid Edge, right? If the arteries are the cables and the lines, then this is the heart. Critical assets, and you have this knowledge and a purview of really the transformers and what they're dealing with and the life cycle of the transformer. From your perspective, what are some of the challenges that we've been able to that exist and that SD Myers has been helping solve?
Well, I think when you get, and you said it when you said the heart of the electric power system, that's the transformer. So the reliability of the transformer is really the reliability of the whole process and all the way through to the grid edge. You know, it's if your transformer has a failure, then everything's going down.
The grid stops, right?
The grid stops.
Yeah.
And so, you know, the ability to look at a transformer and say a transformer's been tested for us for maybe the last 5 years, maybe the last 15, maybe the last 25. In fact, we have one transformer that's still online, and we didn't start testing it at its inception, but we have one that I believe is 114 years old right
Is
now.
that right? So these assets can last a long time,
And now, granted,
if we can monitor it.
that transformer, we started testing it when it was probably well into its 20s or 30s, but regardless, it's been a long time. And the data that you talk about too is it's such a luxury to have data on a transformer for 10, 15, 20 years. Can you look back and you can say, hey, this particular piece of data that I have today is really an anomaly, or you can look at it and say, oh, this has happened before. These are the circumstances by which it happened. So it gives us the ability to really look at things and get a true picture of that particular transformer and what its history has been, and allows us to then do the analytics and say, okay, this is a problem, or no, this is not a concern. You're within the regular performance parameters of that particular unit.
It's got to be hugely valuable to the industry to have that kind of information, especially with these large main power transformers where supply chain has been such a challenge. Even in good times, these large power transformers are just not sitting on a shelf someplace. That goes out. A utility might, or maybe a sister utility might have another one that could come in, but there's a huge value in knowing that information, as these transformers are that key element. We got to make sure that they not only last longer, but that we can predict how they're going to perform so we can respond appropriately, right?
It's so true, and one of the challenges we have coming at us as an industry is we really have an aging infrastructure.
Right.
Most of these transformers were not designed for the grid edge. They were designed for power that's moving in one direction.
Good point.
And they're also not designed for some of the renewable issues that you deal with, where you have power fluctuations and you have times of high output and times of very low. And so there are some challenges coming at us. Can we retrofit these in a way that's not cost prohibitive?
Well, it's interesting you say that, because I was just speaking with a gentleman from SEL, and he said, do you know what the profile of a AI data center looks like when it ramps up and goes to make some processing? He said it looks like a fault. There's just a spike in current, and these transformers have to deliver in that moment. Otherwise, we don't have AI. So this becomes something that we think it's fantastic to have it on our phone, and to think that there's a transformer somewhere that needs to respond in order to get the answer I'm looking for. This is not just a utility industry, industrial facility, data center concern. This is a societal concern, right? We're not going to be. We talk about an AI race, right? National security associated with AI. And to think that our grid and the grid edge, transformers being a big piece of that, the heart of it, you're at the forefront of this race here. That's fascinating.
Yeah, there are many challenges, and we're just now learning what some of them are, and trying to be creative in our solutions and how to address those challenges.
Well, that brings me to my next question, because we've been talking about transformers, how they're the heart of this grid that we're trying to. Well, it's always been that we've wanted a reliable grid, but now we want a resilient grid, and making investments in resiliency, well, there's cost to that. So now we want a sustainable grid, right? We want to be able to sustain this level of resiliency. And so looking forward to some of the challenges that we're facing now or that we're likely to face, what are some of those challenges that SD Myers is working on?
One of the things that we're really working hard is, being able to predict, an upcoming fault, but then broadening our vision to not just looking at a transformer, but looking at a fleet. So if you have a data center, for instance, or any large industrial customer, they're going to have multiples. They may have anywhere from 5 to 75 transformers that they depend on. So the challenge is, okay, how can we look at reliability on a fleet-wide perspective? So we know that, okay, you have X amount of maintenance dollars and X amount of ability for CapEx investment. Which do you replace first? Which do you maintenance? Which do you nurse along until you have the opportunity to fix them? Which do you rehab? What can I take offline and what can I rebuild and refurbish? Those are all difficult decisions, but they have to be made collectively, looking at it from a fleet perspective as opposed to looking at the individual transformer.
Right. Okay. Very good. Excellent. Appreciate that insight. And there seems to be no end to the challenges, not just the known challenges, but it seems that every day we hear about things that we've never heard of in the power industry. If you go back 30 years, it was rather almost a boring industry. It was very well settled on the way we did things, and now we really need to be thinking about gigawatt data centers. This is massive, and building nuclear power plants just to power AI. So we have our work cut out for us in our industry for sure.
We definitely do, and it's encouraging to see the collaboration here and the ability for to look and see who's doing what and how you can integrate, how you can stack your technology to solve some of those problems. That's one of the reasons we come here, is to look and have a better understanding of what's going on around us and how we can integrate with our services with someone else's to improve that reliability from all aspects.
Yeah, that's was going to be my next question. You've almost completely answered it already, which was what is it about Grid Edge that attracts you to come here? Grid Edge, there's lots of other conferences out there, sure, but Grid Edge, well, I'll just ask you, what is it that Grid Edge brings? You said the collaboration piece, and it sounds like SD Myers has been here. This is the second time as a company, but you're personal first.
Exactly.
So what's your impressions of Grid Edge?
My impression is it's an industry that's moving rather quickly with a lot of challenges, but there's also a lot of potential that we're very foundational in what we do, being the transformer experts.
Right.
But we know that there's going to be bigger asks of us because of the expertise we have, and also because our services cover the entire United States. So there's opportunities both geographically and from a technology standpoint for us to learn.
Right.
And for us to have a better understanding of what the future looks like and make sure that our knowledge base and our expertise matches what the future is going to be asking of us.
Right. Well, and what you said about collaboration earlier resonated with me because this is my first time here, and what I've noticed is that unlike some of the other, say, highly specific technical IEEE events, you really have a wide distribution of government, academic, utility, industrial, and vendors all coming together to talk about this segment of our challenge, which is the grid edge, where a lot of the load is happening, or the EV charging happening, the AI is being built into. We've got a lot of challenges in this space, and a very exciting time to be participating in this space.
Absolutely exciting time, and absolutely it's a wonderful time to just step aside sometimes from a presentation and have a hallway conversation with somebody that, and with that presentation or without that conversation, you walk away with a relationship.
Right. It's about
and you walk away with somebody that you can talk to and plan with as you move forward.
Right. Well, Craig, it's been great to have you here. But do you have any closing remarks for our readers?
I think the only thing that I would say is be encouraged. I think there's a lot of very smart, well-trained people that are working very hard to integrate this in a way that I think is going to be very beneficial for the industry. I've talked to a whole lot of folks here, and we've shared different ideas, and there's a desire to have some creative resolve to many of the problems problems not in the negative sense, but just, hey, here's a challenge. How are we going to get past it?
Right. Yeah, a lot of passionate practitioners coming together to solve problems.
Yeah, it's been very encouraging.
Excellent. Well, Craig, it's been great to have you here.
Ben,
Thanks for stopping by.
It's good to see you again.